our RNG program. And then we have Jamie Randolph, who is the principal for our hydrogen program. Is that a little bit better? Thank you. If it does cut out, let me know, because we just working like 3 minutes ago. So.
Yeah.
Just don't in the room, come on.
Okay. I can totally on the room.
What about the podium one? How about the podium?
How's that? Is that better?
Yes.
Yeah.
All right, we will try that. Thank you for letting me know, because I want you to make sure that you hear every word that I have to say, because it's very important. Okay. Well, we got a little bit of a laugh. And I gotta say, I feel kind of like a law school professor, like we're in class right now, where we're gonna talk about the Socratic method for the next 45 minutes. I just wanted to point that out too. Anyway. So PG is part of our climate strategy report. We made a commitment that we were going to be carbon neutral by 2040. 5 years ahead of the state of California. By 2050, we're going to be net carbon beneficial. Are we getting there?
No.
Okay, sorry. By 2050, we're going to be net carbon beneficial. Now, we deliver a fossil fuel, so you can imagine that there's some challenges there to try to decarbonize the gas system and reduce the carbon footprint of the commodity that we provide. At the same time, we need to make sure that we're doing this and providing safe and reliable gas supply to all of our customers within California, while at the same time ensuring that we have affordability while doing so. So how are we going to do that? Today, we're going to focus on the questions around decarbonizing our gas supply, reducing the carbon footprint from the commodity that we serve. There are 4 main ways that we're looking at in doing this. And there's going to be more technologies that are developed over the coming years. But the first one is traditional RNG, next non-traditional RNG, hydrogen, and synthetic methane. Now, I think it's important to have some definitions here to make sure we're kind of level setting on what we mean by some of these phrases we coined. With traditional RNG, it's typically wastewater treatment plants, dairies, and landfills. The advantages of those locations is they're already producing methane. The disadvantages of those locations is that they're typically fixed in location, and they're also fixed in the methane that they can supply on a day-by-day basis. Then there's also non-traditional RNG, which is what we're calling like ag waste and woody biomass, where you actually have to put the organic waste through a process to make your RNG or your natural gas that you would put in the pipeline system. The advantages of those locations is that you can put them just about anywhere, and they're also scalable depending on how much organic matter you have to feed the process. The next one is hydrogen, or what we say clean hydrogen. We take excess electricity that has been generated carbon-free, and we take that electricity, combine it with water, typically through electrolysis. We make that clean hydrogen, put it into the natural gas system. There's no carbon component to that hydrogen, so when you consume it or you combust it, there's less CO2 that's released. And then lastly, synthetic methane, where you take that clean hydrogen, you now combine it with a CO2 source, combine it together, make natural gas, and put it in the natural gas system. In that way, you can make what we call carbon neutral natural gas. I'm echoing online.
We're troubleshooting that now.
Okay.
Yeah, we're troubleshooting that.
Can I turn off the laugh?
Sure.
Testing, how's that? Online? Can we get some feedback online? Did that solve it?
We're getting it. Go ahead and continue.
Got it, thank you. So hydrogen. So introducing hydrogen into a natural gas system has its challenges. But the reason why we want to do it is because we have a $20+ billion asset that is connected to our 4.5 million customers that has an incredible ability to receive, store, transport, and deliver an energy source, which could be hydrogen. Now, this system was designed for natural gas. It's been around for 100+ years. And we first and foremost want to make sure that we can do it safely. What I preach to my team is like the doctor's Hippocratic Oath, right? First, do no harm. We can't do any harm to the system just because of our decarbonization goals.
So some of the things that we're looking at, which are in the R&D report, is pipeline integrity. And when we say pipeline integrity, we're not just talking about hydrogen embrittlement and steels, right? We're talking about distribution, plastic pipe. We're talking about steel materials in transmission pipe. We're talking about regulators and elastomers. We're talking about compressors. We're talking about everything that you would find in a transmission and distribution system. Storage well integrity. So imagine you have over 2,000 pound blended natural gas hydrogen commodity that is on the steel of these storage wells. What's going to happen to the storage wells? Well, we don't know. You need to do the R&D for it. Also, if you have hydrogen natural gas blended underground and it's going to be there for months, what's going to happen? Is the hydrogen going to migrate? Where's natural gas wouldn't, because it's a smaller molecule? Is there going to be stratification between the hydrogen and the natural gas? How do we operate an underground storage facility when you have this combined gas and hydrogen? For safety characteristics, right? Hydrogen is a different animal than natural gas. It's a smaller molecule. It's more apt to leak. The flammability range on hydrogen is 5 to 85%, whereas methane is 5 to 15%. The working around it, having the proper PPE and the testing apparatuses to make sure that you can safely work around it. And then metering accuracy. So when you inject hydrogen into a natural gas system, it's not going to be at a consistent rate, and it's not going to be in a consistent location necessarily. So you're going to have a fluctuation in energy content between your natural gas and your hydrogen blends. Hydrogen has less energy on a cubic foot basis than natural gas does. So how do you properly meter it from an energy content perspective so that we can properly charge the customer? So on the right-hand side of the slide, so compatibility with various customer end uses and appliances. So there are appliances that have been around for decades. Can all those appliances safely combust a combined natural gas hydrogen blend? For the house piping in particular, downstream of the meter, the hydrogen molecule is smaller. Are you going to get leakage on that house line? The emissions testing that needs to occur, indoor air quality concerns, when you combust this now blending occurring at somebody's home. And then deep blending at customer sites. Some customers are going to want pure natural gas. Some customers are going to want pure hydrogen. How do you kind of separate that or de-blend those two commodities once they've been combined together? So one thing that answers a lot of these questions on the slide that I just presented to you is our concept called hydrogen to infinity. This is in kind of concept phase, preliminary engineering phase. We already have a site located in Lodi with partners that have the land as well as the other kind of resources that are necessary to make it successful. But what the Hydrogen to Infinity project concept is kind of a microcosm or a micro example of a large natural gas transmission system. What we've seen in the industry is that there's a lot of R&D in the pure hydrogen arena. There's a lot of R&D in the hydrogen natural gas blending in the distribution system, but there's not nearly as much R&D in the blending at transmission level pressures. And from our perspective, you're going to have to use the natural gas transmission system as part of the equation for a couple of reasons. One is from an energy storage perspective, the natural gas system has thousands of times of storage capability of the largest battery systems from an energy perspective. And also, if you're going to be making this hydrogen at scale, and we need to be making this at the industrial scale, you're not going to put that into a distribution system. You need to put that into a transmission system because that's the only type of apparatus that has the ability to receive, transport, store, and deliver those quantities of hydrogen or hydrogen natural gas. So a lot of the other projects that are going on right now, they're relatively small. They're distribution pressure R&D projects, and they're going to do the project. They're going to get their answer. Then they're going to do another project. They're going to get their answer. In our opinion, because we're running out of time, we need to be doing it all simultaneously. So this facility is designed to have vintage and new pipe, vintage and new meters, compressors, valves, regulators, everything that you would find in a natural gas transmission system in a standalone platform. So if anything does go wrong, if we start to see something that we have an integrity management concern about it, we can shut it out. It's not connected as an operating facility to our natural gas system. On the upstream side, all the hydrogen production areas can now produce their hydrogen at scale in an industrial size system, because then they can send this hydrogen to this large scale hydrogen to infinity project. And then on the downstream side, you have the combustion side. They're going to need to do their testing as well, various blends, various pressures, so they can test their equipment and they can test their emissions on the tail end of everything. This is really all three tranches that need to occur for the hydrogen natural gas economy to work. We already have 130 acres that the city of Lodi has agreed to it. We already have water on site because there's a wastewater treatment plant, ironically, right there, as well as electric transmission and natural gas transmission. So this is ready to go from a conceptual phase, and we're now ready to take this to the next step, along with partners in the industry, because this is not just us. This needs to be partnerships with the entire natural gas utility industry in the country, if not the world, because some other utilities use equipment that we don't use, and we want to bring them in so that they can test that equipment on this facility as well. Switching from hydrogen to RNG. So we talked about traditional RNG. We have a handful of connections that we've connected to already. Really, with traditional RNG, it's getting it cheaper. We have roughly 5 skids that we built, which are the gas quality skids. So the RNG comes into the skid, and then we test it. We make sure that it's natural gas quality that we can put into our pipeline. We need to be scaling that up so that we can reduce the cost, because cost is a barrier to some of these landfills, wastewater treatment plants, and dairies to actually connecting to our system. Imagine now we have 5. Imagine in the future, we're going to have 100 or 300 or 500 interconnections. I could see that happening by the year 2040, because we're just going to need that level of RNG coming into our system. Non-traditional RNG is a little bit different. There needs to be a lot of R&D work in the actual manufacturing of the methane from woody biomass or from ag waste. I know that there's some R&D that's going on right now. That needs to be made operational, needs to be scaled upward so we can bring in those volumes into our system. And then the price of the skid component applies to that particular facility as well. And then lastly, synthetic methane. We take the clean hydrogen, combine that with your CO2 stream to make carbon neutral natural gas and put it in the pipeline system. There's some really exciting work that's going on in that space. And again, from a skid perspective, you need a skid for that particular location as well. So we're, over the past year or so, since we've had our first RNG connection, we've been really proud in the fact that we've had 1 billion cubic feet that we've absorbed into our system that wasn't released to the atmosphere. So imagine 17 years from now, as we're not doing a BCF or 1 billion cubic feet a year, we need to do a BCF a day, every day. So you're talking about hundreds and hundreds of connections to make sure that we can decarbonize the supply that we provide to our customers. So that's everything that I have on my slides. Let me invite the subject matter experts to come up and see if there's anything maybe that I missed that you wanted to opine on before we open it up to questions. Steve?
No, I have nothing to add at this point. Also,
That's covered it.
Okay. Questions?
I'll start.
Hold on, we do have a microphone, so our microphone runner. Jerry Springer.
David. Gary Choquette with PRCI. So green hydrogen, I think that's laudable. And the fact that you've got a wastewater treatment plant that you could work with. So you can also do RNG there, by the way, if you aren't already, right? RNG absolutely should be the very first thing we should go after, because it's a huge net negative for carbon, right? It 25 times the greenhouse gas of CO2, that if you can use it as energy and displace production from the ground, that's a big win. But for the green hydrogen, have you put the pencil together of how much water it would take to do the size of California as a state with green hydrogen? It's massive. I don't know how you're going to do that short of desalination of ocean water. Have you analyzed, just penciled that out at all?
So first, I totally agree with you. The RNG is here and now, right? Because we can introduce it into the system, provided we can clean it up and get good gas quality, because it's designed, the gas system is designed for natural gas, and RNG is just natural gas. From a water consumption perspective, Jamie, comments?
So it does take water, but the power plants that are producing electricity take water right now.
I agree with that, but
So they're looking at other ways to get the water. Some places it's not going to be an issue, like when you can co-locate with a wastewater treatment plant, that's not always going to be possible. So that's where we're looking for different innovations to create hydrogen in ways that don't use as much water. There are some innovators out there that are working on it, but that's not what PG&E is doing. That's what PG&E is looking towards everyone else to help with. And there have been some studies done. I don't have the exact numbers off of the top of my head about how much water that's going to take.
yeah, so pure chemistry, it takes 18 kilograms of water to make 1 kilogram of hydrogen, just on pure chemistry alone. So it's huge when you scale that up. And certainly I like, thinking innovatively. So when you have underground gas storage, you probably get produced water as part of that, right? So yeah, and usually I put that in a disposal well, maybe you can convert that into hydrogen.
Yeah.
But you're gonna have to be creative in coming up with the water.
Thank you. Question back here? Middle of the room?
Hi, Amanda Cran, CPUC. I'm curious, and maybe I don't know if I missed this, but on who you see the most prominent customers of use for the hydrogen. Are you looking at residential, mostly industrial? Are you in the fuel cell vehicle space?
So for this, we're really talking about natural gas hydrogen blends going in the entire system, going to every customer. So we're not specifically targeting necessarily any particular customers because it's going to be a blend.
And
I'm
sorry, can I
add to
just
that
ask?
for them.
Oh, yeah.
So we are also looking at the separation technology though, to serve the customers that do want dedicated hydrogen. So I think that's going to be a lot of industrial customers, a lot of the transportation heavy duty. I think we're going to see a lot of that. There will be probably some power applications as well, but I think we're going to see more of it in industry, at least to start with.
Yeah, because I guess I generally see hydrogen as more of a solution for harder to electrify, industry. And I'm sure you see it the same, but I guess just a follow up to that is, how does this work together with your electrification goals instead of as contradictory? Because it does keep pipelines in the ground, it keeps the gas system. So I'm just curious.
Yeah, so I see it as I see it as complementary, not contradictory. For one, there's the electrification right now, the gas system supports a lot of the electric generation, and we do need seasonal storage of electricity. And even though we heard earlier that maybe that's overrated, I don't think I've seen any other solutions that can store the energy other than molecules for the time that we need it to store it. So if we're not going to be using fossil fuels for that energy to production, we have to have other solutions, and hydrogen is one of those solutions that I see that's going to support that. And it can be long duration energy storage. There can be microgrids where we have a constrained electric system and we need to supply that electricity through other sources as well.
Could I just add one
Yeah.
thing on the blending versus direct use by industrial customers? So this is in my thinking, this is from David Victor at University of California, San Diego. I was talking to him about this topic because I was thinking somewhat in the same lines I see you, thinking about, which is blending really the right use for this hydrogen? And what he pointed out to me, which I thought was kind of insightful, was you have a lot of money through the IRA and the IIJA going towards the production of hydrogen. You don't have any real incentives for the off-taker of that hydrogen or to build the market for actually off-taking it. So when you look at industrial customers, you're going to have to probably have dedicated infrastructure built to supply them with hydrogen. That's going to take a long time to build the demand. Whereas if you start injecting it into the overall natural gas system and getting demand from all of the natural gas customer base, that builds that demand, which then meets up with the supply that's being driven by the government incentives.
So I think we have a question online now. Where to go online now?
Yes, we have one question online. So why use hydrogen when compressed gas in the pipeline will allow you to spin turbines without the cost, will use much less, and is safer?
So hopefully I understand this. We're trying to decarbonize the pipeline system, right? It's part of it. So if we're just relying on continuing to use what's there with the natural gas system, I don't think there's enough RNG supply that's available out there. We have to diversify. I don't know if that answers the question though.
No more questions online right now? Okay. Over here, maybe in the blue with the blue shirt?
Yes, thank you.
Hold on, your microphone's coming.
Going back, I think, to the comment that the gentleman made, have you all thought about the economics of, you produce hydrogen, you blend it in, and then you put a refraction and to consume it, let's say at a fuel cell medium duty vehicle, right? Does the economics really hold? You're doing double transformation there, huh? Sorry.
So you're talking about blending it and then deblending it to serve a fuel cell vehicle?
Yeah.
Yeah, so I think
Or any industrial application, right?
yeah, so there's some economics where they say that there's been some studies by UC Irvine that I've seen that the transportation costs, that midstream is going to be the component that's going to be driving the cost more than anything else. And so there's thoughts that repurposing the existing gas system will be less expensive than transporting through trucks, right, on the roads. And, the end game in the long term will probably be dedicated hydrogen pipelines, but it's going to take some time probably to get those. So if we could blend up to 30% hydrogen into the existing pipeline and then deep blend it, you'll be able to get to scale much faster. And that's really, what solution we're going towards for the short term so that we can help bring that market up to scale. So.
Hi, can you hear me okay? This is Jeff Pickles with Green Grid Inc. I was curious, and I think this is a great project. Is there a mechanism, maybe if it doesn't exist today or is one being thought of, that PG&E would have a open procurement for green hydrogen molecules to really help be an off-taker for a statewide or service area wide network of green hydrogen production plants that could all just benefit from having some steady offtake as the car market is growing, that PG&E can serve a great role to provide that base offtake initially to help us finance the green hydrogen production plants.
David, you want to take that? Probably more in your world than is anybody else's.
I guess my response would be, there's a lot of ways that hydrogen market could develop and end uses that could materialize. So it's very hard for us to think today from a regulatory perspective about becoming that off taker when there's so much uncertainty about where the demand would be and how much we could actually put in our system. I think that's kind of a longer term question that we need to answer, and we probably need to start working on it today. But PG&E is an off taker for a huge amount of hydrogen when we have uncertain demand for it currently. It seems like a tough road to walk.
Can I just add a little bit? So I think if this follows the same path as the RNG, we had to have a RNG interconnection rule first. And once we had that, then there was procurement mandates that came out through the CPUC. So I think it will probably follow a similar path. And so this Hydrogen to Infinity project is going to be part of the joint application of the California Gas Investor-Owned Utilities. That has been ordered by the CPUC. We're ordered to do pilot and demonstration projects for hydrogen blending so that we can determine what that injection standard will be. Once we have that injection standard, then we'll talk about the procurement standards.
And just from a business model perspective, we don't procure the majority of the gas we deliver anyway, right? We're just the transportation agent. The only gas that we procure, it goes to our core market, which is the residential and small commercial market. So we could certainly incentivize that procurement, but again, it's about 20 to 25% of all the gas that we transport. Everything else is done by gas marketers for the larger customers. You bet. Question online?
Yeah, actually, Austin, do you mind just introducing the 3 other SMEs on in the front, please?
Go ahead. They couldn't hear me at the beginning.
Yeah, I'm Jamie Randolph, Principal Hydrogen Program Manager in the Greenhouse Gas Emission Strategies team.
David Sway, I work on decarbonization strategies.
Steve Morligan representing RNG team today.
Okay, we have another question. Is the reason air was not included in your topic categories in this session because PG&E's CAES on King Island is being used as a peak power source only? Then would PG&E upgrade it if it could increase its volume and PSI in some 37,000 abandoned wells?
You say air wasn't included?
AIR.
Yeah, that's a compressed air energy storage system we're talking about.
Okay, so we deal with natural gas, so we're not talking about energy storage with anything other than in the natural gas system. So anybody that's working on that would be outside of our realm. I don't know if you know anything about it, David, or?
I don't know the details of any activities on that. I know it's been discussed, but exactly where we're at with that, I'm not totally sure.
Okay, and one other question. Where is the 5-10-year plan for rolling out hydrogen for commercial, industrial, and residential use? Is there a resource page where we can get information on this?
I don't know if there's a resource page on that specifically. We do have some information about the Hydrogen to Infinity project at pge.com/hydrogen. If you're looking for a 5-10-year plan, it would be more of a California-wide plan that we'd probably be looking at, not specific to PG&E at this point. And and our R&D roadmap also shows what we're working on. That's on the hydrogen website that I mentioned.
But from my perspective, the usage of hydrogen needs to follow the science. So it's irrelevant if setting a 5 or 10-year target if you don't have the science and the R&D to prove out that it's actually safe. So the really important precursor is, can we do it safely? At what percent blend? Once you get to that point where you can do it safely at that percent blend, then you can introduce it at that percent blend and not too early. Can't do it beforehand.
Hi, Chris Ball with Bloom Energy. We have a similar project with SDG&E right now, where we're taking hydrogen through our making hydrogen through our electrolyzer at Caltech's campus, running it through their local distribution network, and then running that blended hydrogen through our existing fuel cell that's already powering the campus. This is right in our wheelhouse, so we would love to participate from either the electrolyzer standpoint or the fuel cell side. As far as getting participation into this project, what's the process like?
So right now we're working on setting up a joint industry project. We're going to be having an administrator chosen probably over the next 4 to 6 weeks. So once that is set up, then we will be formally inviting industry partners to join in the joint industry project. You can also email us at hydrogen@pge.com. There's, if they're still up there, there's flyers in the back that have both the website and the email address.
We'll make it easier in the gray suit. These are right there.
Thanks. Peter Chen with CC. I'm curious what kind of community engagement you've done with the city of Lodi. I know it's early on in the project, but if you've had those conversations with the local community.
Yeah, great question. So the city itself is one of our partners in the project. They own the wastewater treatment plant. We are in the process of setting up formal community engagement meetings. Those will probably be in the late part of this year. But we're planning on engaging with the community members in the city of Lodi and also some of the surrounding community all the way like towards Stockton and possibly up to Galt. So those plans are still in progress, and they will be announced. Once we have the meeting scheduled, they'll be publicly available so that anyone can attend.
Great. And if I could ask a second question, so how do you determine the 30% target blend for this project?
How did we decide to go to 30%? The power plant that we're going to be blending into, the Lodi Energy Center owned by Northern California Power Agency, has an existing turbine that they know can blend up to 30% and most likely up to 45%. So our initial target is to go up to 30% to see if we can support that power plant at the 30% level.
I think there's a question down here. Oh, what, online?
Okay, you mentioned that hydrogen behaves differently from natural gas. Will you be able to evaluate the performance of ignited releases of hydrogen and natural gas blends at hydrogen to infinity to benchmark potential impact radius models?
Can we take that?
You want to take it?
So I think that's one of the things that we're planning on testing, right? Is we need to make sure that we understand the differences in behavior, not only from a combustion standpoint, but also the potential impact radius. The potential impact radius is if you get a rupture in a transmission level pipeline, then you can kind of understand what area it might impact. And so we would have to do at least have to do some modeling, if not some real world testing with those blends. I don't know if you want to add anything.
So PIMS has already done, there's a report on that. It's at the PIR is actually less for hydrogen.
So the comment from the crowd is that PHMSA has already done that report and the PIR is less than with pure natural gas. Okay, another question in the room?
Hi, Jared Lynch from Lawrence Livermore National Lab. I was hoping to hear with the title of this talk that y'all might have had some thoughts about actually carbon capture and storage, if for nothing else than maybe the synthetic methane, but maybe also just wanting to understand PG&E stance on carbon capture as a decarbonization strategy for fuels.
Yeah, no, so I appreciate the question. It's something that we're talking to our leadership as well, is what is PG&E's role going to be in carbon capture and sequestration? And in defining that role, what is the gas department's role going to be on behalf of PG&E? So we don't have those answers yet. And again, on the synthetic methane side, we're not producing it, right? We're just encouraging the production. So we'd be looking for those third-party companies to do the carbon capture and sequestration and then combining it with the hydrogen to make the synthetic methane. But just a standalone carbon capture and sequestration, it's not quite the same as delivering natural gas / hydrogen blends. So it's likely going to be in a different department, but PG&E is looking at that for sure. Because from my perspective, you're not going to get down to zero everywhere, right? It's an equation. And if we're going to get to zero as the net, you're still going to be releasing in some areas. You have to have carbon capture and sequestration to balance all that out, especially when you want to go positive in 2050. So that's absolutely going to be a part of the equation, but it's just, I don't know what PG&E's role in that's going to be yet. I think there's
So anybody who has like new and creative ideas on carbon capture and sequestration, we would love to hear them, and we'll get them to the right person.
So coming to the room was anybody that has ideas for CCS was to bring those ideas as well back to the Pitch Fest in September. I think we'll do one final question back in the room. Right where you're at, David.
Last question.
Last question? You had a question or no?
No.
Okay, got it. One question up here. He's coming safely.
Really interesting project. My name is Eric Cohen with SoCal Gas. I'm curious about the scale of how large the generator is, and then what you guys are thinking about for storage. And then I guess the last question would be, how do you expect the capacity factor of the generator to change after you are using 30% hydrogen blend?
Yeah, so there will be some dedicated hydrogen storage, above ground storage. And then also in the test loop, the online test loop for the hydrogen to infinity, it's going to be a 1 to 2 mile pipeline. So there will be, storage just within the pipeline there. For the capacity of that power plant, I believe it's 250 megawatts, I believe, approximately. And right now, I think they've been running around like 70% capacity. I don't know if that will increase if they're decarbonizing it to be run more frequently, but it is not a peaker. It's a fairly new power generation station that they installed that turbine in 2020. And so it's one of the fastest starting and cleanest burning natural gas power plants that we have in California right now. It's owned by NCPA though, not by PG&E.
Well, that's all the time we have today. Thank you, everyone, for coming. If there's additional questions, feel free to ask us at the break. We'll really appreciate it.